Science and everyday life cannot and should not be separated. Every great leap forward starts the same way, with resistance. Chemistry shows us why some sparks fizzle and others set the world on fire. Why some ideas stall while others appear to explode overnight. And why the right mix can forge something unbreakable. And in this video, I'll be breaking down the 3 most powerful mental models from the chemistry portion of this book, The Great Mental Models, Part 2. There's at least one time when it's okay to lie to yourself, to get the activation energy required to start a new project. Paul Graham. Activation energy is the minimum amount of energy required to start a reaction. If we have enough activation energy, we can power a reaction through to its conclusion. All right, take these matches for example. If I was to rub this match against the striking strip gently, nothing happens. But if I strike the match against the striking strip, it crosses the threshold of activation energy required to initiate the chemical reaction and light the match. Kind of breathed it in. Now, one of the most important aspects of activation energy is that in a lot of cases, you need enough of it not just to initiate the reaction, but to actually power the reaction through to its conclusion. Now, if I wanted to get a sizable fire going by holding this match up to a big log, the log wouldn't catch. But if I lit some newspaper on fire, and then to that newspaper, I added some small sticks, and then maybe some bigger sticks, I could sustain and grow the reaction long enough to get a nice fire going. You see, this idea of needing enough energy to power the reaction through to its conclusion is why revolutions are so difficult and often unsuccessful. In the 1980s, there was a revolution led by Thomas Sankara in Burkina Faso. Corruption, poverty, and all sorts of inequality provided the fuel to start the fire and begin the reaction that led to sweeping reforms under his leadership. When he was elected president in 1983, he tried to lay out enough kindling so that his vision for the country of Burkina Faso could eventually become self-sustaining. But when he was assassinated 4 years later, the country was taken over by the old order that valued corruption and concentrated wealth in the hands of a few. In short, the reactions that Thomas started didn't have enough activation energy to continue on their own once he was gone. Now, when I first started reading about activation energy, it reminded me a lot of inertia, and I thought that maybe they were the same thing, but here's how they're different. Inertia is the tendency to resist a change in motion. Activation energy is the force required to overcome inertia. It's basically the minimum input of energy to make it happen. And as we just discussed, it can also be used to describe the hurdle you have to clear in order for the reaction to sustain itself. In terms of personal growth, it's the effort required to break old habits and to form new ones. The authors round out the chapter by saying this: the key is to recognize activation energy for what it is, a necessary upfront cost, not a permanent obstacle. Once things are moving, momentum takes over. Once the reaction starts, it becomes self-sustaining. All right, our next mental model is catalysts. Catalysts accelerate change. They can't make a reaction happen on their own, but they can significantly reduce the amount of time it takes for a change to occur. Catalysts are value neutral, meaning they could speed up a negative reaction just as easily as a positive one. Something important to note is that a catalyst is used without being consumed in the process. In other words, it doesn't get used up. Let's use digestion as an example. Breaking down a molecule of starch into sugar would normally take a very long time. In fact, the food you eat would rot in your stomach before it could be converted into a usable energy without catalysts. Now, fortunately, your stomach contains enzymes, biological catalysts, that make this transition happen in milliseconds. The enzymes don't get used up in the process, they just make it happen way faster. All right, let's use an example from history. The invention of the printing press was a profound catalyst. It accelerated the process of obtaining knowledge by creating a repeatable system for copying knowledge. Books. Before the printing press, scholars would have to actually travel to scriptoriums to get their hands on one of Aristotle's manuscripts. The invention of the printing press made books a whole lot cheaper and way easier to make, meaning that they were more widely available. Knowledge now required less money and less time to obtain, meaning that the activation energy threshold had been lowered. In business, a catalyst might be a new technology that opens up new ways of delivering a product or service. In our personal lives, a catalyst could be a life-changing book. In fact, other people can be catalysts to us when they help us to realize our potential. And we can be catalysts to others when we help them find the activation energy needed to accelerate a change. In chemistry, alloying is the process of mixing two elements together to create a new material with superior properties. In other words, when mixed together, the result is greater than the sum of its parts. Around 5000 BC, civilizations worked almost entirely with copper. It was a very useful material, but it was still too soft to make decent tools and weapons from. Then the Sumerians discovered that if you mixed around 90% copper with around 90% tin, you would get a new material called bronze, which was super strong. Bronze was stronger and longer lasting than copper or tin on their own. This discovery reshaped entire societies. Stronger plows meant more food. Better weapons shifted the balance of power. Architecture was greatly improved. This marked the beginning of the Bronze Age, not because a new element was discovered, but because two elements were mixed together to create something new that was extraordinary. One of the greatest examples of social alloying is the Renaissance era in 15th century Florence, where geniuses and artisans were brought together. Here's a little passage from the book that I'm just going to read aloud because I absolutely love it. This mixing of ideas from different disciplines became the norm as people of diverse talents intermingled. Silk makers worked with gold beaters to create enchanted fashions. Architects and artists developed the science of perspective. Shops became studios. Merchants became financiers. Artisans became artists. Basically, alloying shows us that the right combination can create qualities that don't exist on their own. All right, so that wraps up the chemistry section of The Great Mental Models Volume 2, but there's also a physics section and a biology section. So if you like this video, you'll probably also like the videos that I made on those other two sections, which I'll link somewhere on screen. And this book is actually Volume 2 of a 4-part series. And the original Volume 1, The Great Mental Models, I made a video about that. That has just gone absolutely viral. It has over 250,000 views. So if you haven't seen that yet, check it out. I'll see you over there.